I'm going to show you 8 different examples of how to divide fractions like this and like this. Let me show you pretty much the reasoning as to what I'm going to show you why it works. So I have to divide by 1/4. I'll put a model here so you kind of see why it works. But essentially when you're dividing, you're trying to determine how many times this piece fits into this piece. So this is the model for this problem here. 1/2 divided by 1/4. This is 1/2 and we're dividing it by 1/4. And to figure out how many times this fits into here, it helps to make this the same number of size parts as this one. So since we have 4 parts here, I'm going to cut this up into 4 parts as well. So pretty much you can see my before and after. I took the half and I cut them each into halves. So now I have 4 parts here, 4 parts here. And again, the question is how many times will this fit into this? So I can see here clearly that this piece will fit into here not only once, but 2 times. So that means that when I divide this out, my answer should equal to 2. Now, by making these the same size parts, the process behind that is simply finding the least common denominator. So essentially, you're trying to make it the same size slices. So I'm going to find the least common denominator here to show you how this looks like without pictures. So as a quick refresher, when you find the least common denominator, you look at your bottom 2 numbers, and you're trying to find the least common multiple of 2 and 4. Meaning if you count by 2s and count by 4s, what's the first number that matches up? And you can see here that's easily going to be the number 4. So since that's already the number 4, that means I got to change this to a 4 by multiplying it by 2. And what I do here, I'm going to do the same thing to the numerator as well. And just to see why we do it to both, you can see here in the visual that I have one part that's shaded, which represents your numerator. That one part became 2, so we doubled it. And then overall, there were 2 slices, right? We started with 2 slices. And they also doubled overall, right? We have 2 slices, now we have a total of 4. So essentially, you doubled each of these, so you have to do that for both of these. And now when I simplify, I'm going to get 2/4 here divided by 1/4. So 1/2 and 2/4 are the same, which you can see here. This is 1 out of 2 shaded, 2 out of 4 shaded. So essentially, they're still both half shaded. The only difference between 1/2 and 2/4 is the number of slices we're looking at. And now, essentially, when you get to this part, common denominator, all you're trying to do is figure out how many times did that shaded part fit into this shaded part, which represents the numerators here. So essentially, we could ignore the denominators and we're just doing what is 2 divided by 1, which in this case is just going to be 2. So that was one way, but you probably haven't seen it that way before. Here's the way you've probably been taught, the keep, change, flip method, where you keep the first value and you change division to multiplication, and then you flip this fraction, the second one, which is called the reciprocal. You flip it around, meaning switch the numerator and the denominator, switch their places. And essentially what you're going to do now is you're going to just do like you've been working on before, where you're going to do the prime factorization. I'll do it for this one. And then keep the 1 the same. So that's all we have to factorize here. And then we get 1 times 2 times 2. Because when you multiply fractions, you multiply the numerators together, your denominators together. And you always want your answer in the simplest form. So we look for eliminating the common factors. So in this case, I have a pair of 2's that are common factors here. And whatever's left is going to be my final answer. So I multiply these together, I get 2. And my denominator is 1. And 2 divided by 1 is equal to 2, which is my final answer. So 1/2 divided by 1/4 is the same thing as doing 1/2 times 4. And just to show you a quick model, this you can see here, this is a half times 4, right? We have 1/2, a total of 4 times. So that represents a half times 4. And now if you look at here, I took the 1/2 times 4, and I took the shaded region, and I pretty much just regrouped them into these slices of 2. So basically we have 4 total halves. I put each of these halves into here, and you can see that essentially these 4 combined actually make up 2 whole amounts. And that's the same answer we got before using the other method I showed you, which shows you that you can use either method and get the same answer. But again, this is the most common one you'll probably see. So that's just a little intro as to why the keep, change, flip works. For the remainder of this paper, I'm going to use the keep, change, flip method to solve each of these problems. So the first thing you're going to do is you write keep, change it, flip it. So 1/2 times 7/3, and remember your numerators are multiplied together, you multiply your denominators together. These are all prime numbers, so I already know that I'm able to see the common factors right now, which there aren't any. Since there are no common factors, multiply the numerators together, denominators together, and 7/6 is the final answer. I know this is simplified because the definition of simplified means there are no common factors between the numerator and denominator. And again, that's why we do the prime factorization like I did over here, because it exposes which ones they have in common. Here's my third example. So again, you keep it, change that one, flip that one, you get 11/3. So I multiply the numerators together, my denominators together, and you can see there's no common factors here. So I would just multiply them, and I get 11/9. Here's example number 4. So I keep the first one, change that to multiplication, flip the next one. And now these numbers are bigger, so I want to make sure my answer is simplified, so I have to take each of these and do the prime factorization, which I'll do over here on the side in order to keep my work organized. So I'm going to do this work on the side so you can see, just for the first example, and then I'll go through a little bit faster in the rest. So 27 is the same as 3 times 9. 3 is a prime number, so I'll circle that. I'm going to keep it. 9 is not prime, it's composite. And it's composite because I could come up with other factors besides 1 and 9, and that's 3 times 3. These are all prime, so that's my prime factorization for 27. So to keep my work organized, like I said, I keep the work to the side. Then I'm going to bring this back together over here. 3 times 3 times 3 represents the 27. The denominator is 32, so I'm going to do the prime factorization for that next. Two numbers that multiply together to give me 32 would be 4 times 8. These are both composite, not prime. So I could break it down further. 2 times 2. This will be 2 times 4. These are all my prime numbers. This is not prime, so I'll break it down further, and I get 2 times 2. So prime factorization for 32 would be 1, 2, 3, 4, 5 2s. So I'll put that over here in place of my 32. That's going to replace it. So I have a total of 5 2s there. Bring down the multiplication sign. Same thing for this one, 16. Prime factorization for that one. I'll do the work to the side to keep my work organized. That's 2 times 8. This will be here 2 times 4. And this one here, 2 times 2. So again, keep breaking numbers apart until you end up with only prime numbers. Remember, prime factorization just means this times this times this times this equals 16. So now I have 4 2s there. 1, 2, 3, 4. And my last number is number 9, which I already did the work here. You can see 9 is 3 times 3. So I'm just going to put that here. So you can see here all my work to the side, and now it's a little more organized. And what I recommend in the next step is to, since we multiply all the tops together and the bottoms together, a common mistake I see is that you forget to cancel out some numbers, or you forget to transfer certain numbers down. So just be careful, but I recommend reorganizing this. So I like to pretty much multiply all these together on one, and the same thing for the bottoms. And I put it in least to greatest order. So I have 4 2s here. 1, 2, 3, 4. 3 3s here. 1, 2, 3. Then for my denominator, I have 1, 2, 3, 4, 5 2s and 2 3s. 1, 2, 3, 4, 5. And then 2 3s. 1, 2. So I like to organize it this way because it helps me figure out what the common factors are a little bit easily. So now I'm going to go ahead and eliminate the common factors. Right? There's no more pairs of 2s, and I have another pair of 3s here. So my final answer I can see is just a 3 and a 2 left. So my answer to 27 32nds divided by 9/16 is 3 halves. And the next problem, 4/5 divided by 4/5. So a couple ways to keep in mind for problems like this. If you have a number, as long as a is not equal to 0. So again, a, just think of a as it could be any number. So if you have a number and you divide it by the same exact number, as long as it's not 0, the answer will always equal 1. So here's an example of what I mean by a divided by a. I have the same number, the 4/5, divided by itself. So I know the answer to this one is just going to be equal to 1. So if you recognize it, good, save you some time. If you don't recognize it, we just go through the process. 4/5, right? Keep it, change that, flip this one. So we know we're going to multiply numerators together, 4 times 5, and my denominators together, 5 times 4. I know this is not a prime number, but since these are common factors, I know that's going to cancel out. These are common factors, cancels out. If you ever end up canceling all the pairs of numbers, just recognize that this is just really the answer 1 over 1, and 1 divided by 1 is equal to 1. So same answer as before. So any number divided by itself, it'll equal 1 as long as you're not doing something like 0 divided by 0. That's undefined. All right, next one, keep the 3 halves, change that to multiplication, flip this one to 10/3, and we're going to do 3 times. This number is small enough that I know I could just do the prime factors. That's just really 2 times 5, and 2 times 5 are prime numbers. And then at the bottom, we get 2 times 3. So my denominator, numerator. And here, I notice I didn't really organize it. It's not too many numbers, so it's pretty difficult to lose track of them. So I didn't really organize it in this case. So common factors are 3s and a pair of 2s. So I'm left with a 5 in the numerator, nothing on the bottom, so it's really just 1. And 5 divided by 1 is equal to 5. So here's my next example, 30 over 50 divided by 30 over 75. So same as before, I'm going to keep the first number, change out the multiplication, and then flip the next fraction to 75 over 30. And sometimes you do get lucky and you'll notice that these factors here, I could go over here and do the prime factorization, right? 2 times 15, 3 times 5, and do the same thing for this one. But you're going to notice that if I do the prime factorization for 30, it's 2, 3, and 5. If I do it for this one, same thing again, 2, 3, and 5. So I already know that these two are going to cancel each other out, right? Those are common factors. So we're really just left with 75 over 50. And similarly, if you do know your multiplication facts, it might save you some time because we have 75 over 50. And I recognize 50 is really just 2 times 25. And 75 is 3 times 25. If you think of it like change, right? 75 cents is 3 quarters. 50 cents is 2 quarters. So you can see here 25 is a common factor. That cancels out and we're left with just 3 over 2. But if you didn't recognize that, then we could always do it the same way as before. 30 over 50 times, so keep it, change it, flip it, 75 over 30. And similar to before, prime factorization of 30, which I already did, will be 2 times 3 times 5. 2 times 3 times 5. The 50 breaks down to 2 times 5 times 5. 2 times 5 times 5. 75 is just 3 times 5 times 5. So I'll replace that. And then my 30 again is the same as that one, so 2, 3, and 5 again. And I'm going to reorganize this. So you can see here, all these multiply together, all these multiply together on the bottom. I just rearranged the smallest to biggest. You don't have to, but it's just more for organization. Because again, the common mistakes I see, it deals with organization when you end up with a lot of factors. So these are gone, these are gone, these cancel out, this cancels out, and this cancels out. So you can see here I'm left with a 3 and a 2. So my answer here, again, is 3 halves. And then my last example is 100 over 30 divided by 50 over 60. So I'm going to organize my work by doing a prime factorization off to the side and keep this area clear for my final answers. So 100 breaks down to 2 times 50. 2 is prime, this is not. And I already know from my work over here, 50 is just 2 times 5 times 5. So I'm just going to go ahead and do the shortcut here, 2 times 5 times 5, because I already did the work over here. So I'm just saving some time. 30, again, I already did it over here, so I can use the work from over here. 50 is already completed. I did that one over here. Same thing as this one here anyways. And then 60, I didn't do, but I know that I can break it down. So 60 is just 2 times 30. 2 is prime. And then I remember that the 30 was just 3 times 2 times 5. So this, I can save time, is just 3 times 2 times 5. So if you did the work in a different problem, just recycle it, use it again, save time. And just like before, keep, change it, flip it, and then I'm just gonna put my work in here, 2, 2, 5, 5 for the 100. So this 100 is replaced with that. The 30 is the work from over here, 2, 3, and 5. So I'll put 2 times 3 times 5. The 60 is 2, 2, 3, 5. 2, 2, 3, and 5. And then 50 is just right here, 2, 5, 5. 2, 5, and 5. And now I'm going to reorganize my work here. So smallest to biggest, I have 1, 2, 3, 4 2s. 1, 2, 3, 4. And I have 1, 3. And 1, 2, 3 5s. 1, 2, 3. And as a safety check, I have 1, 2, 3, 4, 5, 6, 7, 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. Just to check, because again, the more numbers you have, more likely you're going to mess something up by forgetting to write something down. And then you see here, 2, 3, 5, 2, 5, 5. I reorganize it. 2, 2, 3, 5, 5, 5. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 numbers. Last step is to eliminate the common factors. So I have a pair of 3s, another 5, 5, and 5s. So I'm left with a 2 and a 2 on the top, nothing on the bottom. So 2 times 2 is a 4. If there's nothing left, you know it's just a 1, and then 4 divided by 1 is equal to 4.